Welcome back to my channel. Today I've decided to take us through a couple of common patterns that are generally present in algorithmic interviews. Right? These are patterns that tend to recur a lot in questions. There are a couple of them, and this is not an exhaustive list, but I can guarantee you that if you have good knowledge of these patterns currently on your screen, you would be able to solve a significant amount of problems. You would see that your skills, remarkably improve. So the first pattern on this list is the prefix sum pattern. Now, what is this prefix sum pattern? I think that we should probably take some time to try to understand what it is. Now, the prefix sum pattern overall idea is that it allows us to be able to, in constant time, be able to say what the result of a computation is for a range of values. Right, so I'll give an example now. If we say that, for example, say that we are giving an input of arrays, say an input of an integer array. Say we are given an integer array n, where n is an array of values. Say values 3, 4, 5, 9, like that. And we expect that we are supposed to perform some pre-computation and then be able to answer queries of the nature of what is the sum of values between a range. Now, to answer this kind of question, usually what will happen is, say for example, we are asked you, okay, so the first input range is range 0 to 2. Yeah, so what we would expect from this is that you take this input value, start from index 0, yeah, and go ahead to sum it with index 1 and then index 2. So at the end of this output, what we see is that we have a value of 3 plus 4 plus 5, which gives us a 3 plus 4 is 7, 7 plus 5 is 12. That's 12. And we can have another input that says, okay, give us a value of 1, range from 1 to 2. Now that would be from 4 to 5. Yeah, in this case, that would be 4 plus 5, which will give us 9. Then we could also have another input that says, okay, give me the value of the sum from 0 to 3. Yeah, so in this case, we need to now say 3 plus 4 plus 5 plus 9. That will give us 12 plus 9, which is 21. Then another input can come and be like, oh yeah, give me the sum of values from the range, let's say 1 to 3. In this case, we'll have 4 plus 5 plus 9, which is 18. So if what we notice is that for each of these queries, it seems that we need to perform a linear time operation. So if we analyze the time complexity of each of these queries, we realize that at every single point, we need to loop through the input array. We need to loop through this input array and then go ahead to sum all the values one by one. But is there a faster way to do this? So technically, all we've been doing since is O of n regarding time. But is there a faster way to do this? Actually, there is. There's a faster way to do this, and this faster way involves being a little bit smart. What do we do in this case? So in this case, we use the concept of the prefix sum. So this is where prefix sum actually shines. And what we simply do is we say that we are going to sum up every value here with the previous value. So what that will mean is that we'll have a new array that will be created. So this you can call it NP, prefix sum array. And the values within this array will be the sum of all the values from the index 0 all the way to a particular index. So if I say that the value at index position 0 will be the sum of values from the index position 0 up to that index, so definitely here will be value of 3. Just bear with me for a moment, it's about to make sense. So at index 1, the value at index 1 will be the sum of values from index position 0 all the way to index 1, in which case here is 4. is 3 plus 4. That's 7. The value at index 2 will be sum of all the values from index position 0 all the way to position 2, which is going to be 3 plus 7 plus 5, which is 12. And the value at index position 3 will be the sum of values from index position 0 all the way to index position 3, which is 3 plus 4 plus 5 plus 9, which is 21. I don't know if you noticed something here, but we didn't actually need to go ahead to accumulate all the values in all the previous indices for every index that we are in. We didn't have to, for example, at index 2, we didn't have to go all the way to index 0 to add 3 plus 4, to add 3 plus 4 plus 5, 3 plus 4 plus 5 to get the value of 12. Same thing at index 3. We didn't have to go all the way from index 3 to 4 plus 5, 3 plus 4, 3 plus 4 plus 5 plus 9. We didn't have to do all of that. There was no need. We could do this in a form of cumulative fashion. Yeah, so what that means is that in one go, in one sweep, we can get out all the sums. Yeah, so that will mean that for every index, as we are moving through, we are setting the values. So initially, we will have 3 here for index 0. Then at the next index, we just do whatever it is that is at this index plus the previous index value of this cumulative. Yeah, so let's just write cumulative here, so that's sort of suggestive. So to here now we have 4 plus what we have here previously now becomes 7. The next index is 5 plus what we have here previously is 7, now becomes 12. The next index is 9 plus what we have here previously becomes 21. As you can see, these arrays are exactly similar. This is the concept of prefix sum. It can be done in a single linear time operation. Now, once we have this prefix sum in a single linear time operation, we can, in constant time, answer all of these queries. And how do we do that? Let me show you. For the first query, we are requested to get the sum of the values from index position 0 all the way to index position 2. What we simply do is, just get out the value of all the sum of values all the way to this index. So in this case now, remember this is our input. We have 3, we have 4, we have 5, and we have 9. So we want the sum of values from this index all the way here. Remember, we already have that, isn't it? That's the value of 12. That's the actual definition of the value of 12, what we calculated initially here. It's just simply the value from here to here, which is 12. However, with prefix sum, a general idea for solving these problems is to just say that get the sum of the values all the way to this right index and subtract it from subtract the value of the sum of the index on the left minus 1. So what that means is we need to get, I think I should use an example so that it's much more clear. So let's use this index 1 to 2. So now in this case, we need to find the sum of the values from index 1 to 2. Now this is just let's use the same image. So this is our index 0, index 1, index 2. So we need to find the sum of the values from here to here. In our previous approach, we had to perform a linear time operation of going all the way to that index 1 and summing all the values all the way to index 2. Yeah, but in this case, we already have our prefix sum array. What we simply need to do is we just say, okay, to get the values of the sum of values from this index all the way to this index, we just need to sum all the values all the way from index 0 all the way to the end. Remember, we already have that, a constant time operation. And then we now need to subtract the sum of the values in this position. Alright, so let me make that a little bit clearer with a different marker. So what we are saying is that we are going to take this sum and then we're going to subtract off this sum. And if you notice, this is index 1, this is index 2. This is what we're looking for. And definitely it makes sense, right? Because all of these sums here subtracted by this is going to give us this left. And that makes sense, isn't it? So to prefix sum, with the prefix sum in constant time, because this is a constant time operation now, you've reduced this problem from being a linear time operation to a constant time operation. In constant time, we know what the value of all the sum of all the values from index 0 all the way to index 2. We know that value. Yeah, 0 to 2. We know it. We know that 0 to 2 gives us 12. We also know the sum of the values from index 0 all the way to the index just before this left point, just before this lower point here, which is what this is going to be. So mathematically we say left point minus 1, in which case the left is 1 and that will be 1 minus 1, that's 0, which is index 0. So some of the values from index 0 to index 0, we know what that is. It's in this array already. That's 3. So automatically the sum of the values from index 1 to index 2 is simply a subtraction of these two, and that gives us what? That gives us 9. And if you evaluate that with our previous approach, we see that we do a 4 plus 5 gives us 9. The difference now is that in constant time we can be able to answer this query. So we could evaluate it for the different examples and then see what that gives us. Yeah, so for index 0 to 3, we do the same thing. Yeah, but this time around, because 0 is the leftmost border of the array, of the input array, we can't go beyond it. Yeah, so once we have a value of 0, what we can simply say is, okay, so if we have a value of 0, we just need to return back some of the values up to the index on the right. And in this case, this is this index on the right here, 3, and which is this 21. So this is 21 automatically. So we already have that here, as you can see. We've evaluated that initially as 21. Same thing too we could do for the final one, 1 to 3. And then realize that what we simply need to do is sum of the values from 0 to 3 minus sum of the values from 0 to 1. No, sorry, 0 to 0. Remember, so this will be left minus 1, which is 1 minus 1, which is 0. Alright, so now this 0 to 3 is, according to what we have here, this is 21. And then 0 to 0 gives us 3. And then when we subtract these two, we have 18. So do we see? We prefix sum. So usually for problems that tend to give us a range and then expect that you'd be able to give out the value or some of the values within a range, that's where the prefix sum sort of shines. Alright guys, that's all about the prefix sum pattern. As you can see, it's a really important pattern that is important to be in your arsenal so that you can be able to attempt some algorithmic problems. And thank you guys. See you soon in another video where I'll be talking about the next pattern on the list, the 2-pointer pattern. Bye guys.